They're available for download at systemviz.com, and they're all kind of free and open source. So you can access that whenever you want, although we circulated the visual vocabulary in advance. So let me tell you a little bit about myself. So I like to think of myself as wearing 3 different hats. So on the first hat that I wear is that I'm an interdisciplinary social scientist. I'd like to do research on various topics, sociology, economics, political science, psychology, all these sorts of things. I like to kind of jump around the various disciplines in order to develop a more holistic understanding about how people work in society. But the other hat that I wear is I am also a management consultant. I've tended to work within civil service academies, so I've done a lot of work. I've done work in Canada, South Africa, Brazil, Jamaica, in the Caribbean more generally. Sometimes in business administration, but with a very strong public sector orientation. And this has tended to be in 2 areas. One is governance, and the other is service design, which allows me to do all sorts of different things related to public administration, broadly defined. And my whole philosophy is to try to find better ways of bringing social science ideas and design ideas into management consulting, because I have a lot of problems with the way in which a lot of management consulting is being done these days. The third hat that I wear is that I'm also an information designer. So a long time ago, it occurred to me that it's very hard to get people to pay attention to ideas unless you find new and interesting ways of presenting it. Like an information designer is, on the one hand, someone who I guess my definition is someone who orchestrates words and visuals, sometimes sound and motion, in ways that better communicate ideas. So information graphics and animations and learning materials and these sorts of things are very much intertwined into the work that I do. And you're seeing a little bit of that with the visual vocabulary and some of the things that we're going to be discussing today, which are all about new mapping techniques for systems. So I'm based in Ottawa, in Canada, but also I'm also based in Tokyo sometimes. But I travel around the world. Here are some photographs of my places where I've done work. And the other important thing to note is that I guess since the late 1990s, all of the work that I've done as a researcher or a designer has been participatory in orientation, or what we used to refer to as action research at the very beginning, where we'd bring a group of stakeholders from within say a community or across various expertise, and we'd have them steer a research or a design project. Sometimes these took place over the course of a year. In Canada, we ran 24 action research projects, and we did another 3 in Brazil and 1 in the Caribbean. Plus, I've done basically most of what I do is in some way a form of participatory design. And so everything that I do involves getting people, including people who might not be experts on a subject area, to be better able to communicate and discuss ideas. And so a lot of what I'm going to be discussing today will be about one such tool or some tools that help people get on the same level when they're talking about something as complicated as systems. But of course, we're now doing e-participation because of the pandemic. So what's going to happen today is going to be a little bit experimental. But I've developed a little bit of experience here, and so we should have a lot of fun playing with some of these tools. So let's get to discussing system mapping and the main idea here. So let me start by mentioning my project. So System Viz is a side project of mine that's intended to further the field of systems in terms of visualization, but also to kind of pull out and develop systems theory in ways that can be more approachable and more useful to practitioners. So this has been going on for about 7 or 8 years now, and there's a number of phases to this project, and we're going to discuss 2 of those. Now, first, let's mention a few things about what a system is. Here we're talking about it. It's basically, a system is a set of things. It could be people, cells, molecules, or whatever, that are interconnected in such a way that they produce their own behavior over time. So that's a very broad definition. And we have a number of different types of notation styles and shorthands for mapping out systems or displaying systems. And so the project that I started off doing was to create a big inventory of notations and look at which ones were better, what the emphasis of each one was, in the hope that I find this ideal, perfect notation style that makes it very easy to map out systems. And that never happened. I couldn't. I've developed a big inventory of them, and I'm going to publish that work eventually in terms of a guide that helps people understand systems mapping. But I did learn a lot about what I didn't like about some of these notation styles. So I'm going to mention a few of these and some of the areas where I think we can do better and where I think the visual vocabulary does a slightly better job. So we have things like flowcharts, which list out mechanical systems in terms of very linear, kind of stepwise progression through a system of decision points. And one of the challenges with a graphic like this is what I call the abstraction trap, which is when we decide to map out systems as a bunch of circles and squares with these text labels and maybe some arrows, we often lose sight of what the underlying reality is. We often have a difficult time imagining what it is that we're talking about and absorbing it in a kind of immediate or glanceable way. And also we find that some of these flowcharts also come in lots of different kind of technical variations, from engineers to database managers to logistics people, and all of things to hold in your mind at once. And so one of the problems with some of these notations is that they get very complicated very quickly. Now, one of the more simple ways of just of mapping out a system is to just simply draw a bunch of linkages between various topics. And that's a great foundation. Concept mapping, or sometimes mind mapping, or these sorts of approaches can be really valuable. But one of the challenges here is that when we're drawing linkages between these different items, we sometimes neglect to explain what it is the relationship is. Because a linkage can mean all sorts of things. And with a system, so much of the most important dynamics and interactions are represented by those arrows that often go undefined. And so we try to define these as well with very simple text labels, or we can kind of show various loops and how a system kind of intertwines or mixes together in interesting ways, and start labeling those loops as well as just the linkages themselves. And this can get very complicated, even if you're doing things like color coding different sections of the system. And here we develop a number of problems, one of which is the spaghetti problem, which is it all starts to look like a big bowl of spaghetti after a while, where there's all sorts of these noodles kind of all over the place. And it's very difficult to pull out individual pieces or see a bigger picture or see important pieces of important priority items. Moreover, sometimes we're often comparing things that really should be that might not be appropriate or are not analytic, or a bit analytically sloppy, which is to say, we're not comparing apples and oranges, as they say. We're comparing apples and atoms. So radically different levels of analysis can sometimes sneak into some of these diagrams that make it very that are actually starting to smuggle in lots of assumptions about how two items kind of relate to each other. There's often a lot happening in between. So one of the things that I do with the mapping is to try to pull out different levels of analysis, pull out different subject areas first, and then map those, and then draw the linkages across those areas, as opposed to creating the one big diagram that tries to explain everything. And here's an example from the United States government that shows Afghan stability. And it's very difficult to jump into the graphic like this. There's some prioritization of items because some of the text labels are very large. And there's some color coding taking place to indicate different types of subject. But what you're really having a problem with here is the parsing problem, which is the eye has very little is guiding the eye. It's very hard to kind of figure out what the main lines of sight are within a graphic like this. Where are you supposed to look first, and what are the types of paths you're supposed to follow? And moreover, it's hard to really care about jumping into a graphic like this when it just seems like a big mess, right? And we also have a problem with equivalency, which is sometimes some topics are really, really important in a system. They have a really big impact. And some items have a very small or minor role. And a graphic like this does a very poor job of emphasizing what the more important and less important things are. Essentially, a graphic like this is just saying everything's connected to everything else. And that's not very analytically rigorous, right? We want to know a little bit more about what are the more important things and what are some of the less important things in order to develop, like in the world of governance, to try to develop priorities and find the right leverage points in which to intervene, right? So my big lesson from surveying all of these notation styles, and I have dozens of other ones that I could have gone through, some of which are very technical and hard to learn, and some of them, but the key takeaway point is that a lot of these methods of visualizing systems also have a certain bias to them. They have a certain idea about what a system is, whether it's kind of stocks and flows, or whether it's decision points, or whether it's boundaries and signals or things like that. And each one has this emphasis, and that's not really comprehensive or fully representative of what a system could be. So that led me to naturally gravitate towards another area, and one that I'm more passionate about, which is the idea of diagrams or information graphics. So here's an example of an alternative energy source, which is geothermal electricity. And here you'll notice a few things. One is that you see the entire system represented here.
Sorry to interrupt, but it's just that we are seeing a small gray window on the right side, and it's blocking your presentation. I'm sorry, I thought it was something from my computer, but they just told me that everyone is seeing it.
Okay,
So
let
maybe
me
if you could close it,
stop.
please.
I'm going to stop the sharing and I'll try
So
again.
that we can appreciate the whole graphics.
Okay.
Have you found it? It says build order.
Okay.
The build order window on your right.
Oh, build order window? Oh, okay.
That
That one.
Yes.
That's weird.
I was blocking a part of the presentation.
Very strange. Okay, so here we go.
Thank you, Peter.
That work? Okay, build order.
Yes.
Strange. Okay, so this is a diagram, and there's a few things here to point out. First of all of this more salient or more important items are kind of pulled out so you understand where the energy comes from and how it flows through a system, where the water comes from, all these sorts of things. And instead of having just squares or circles with labels, we have actual pictures of objects that give you an indication of what they look like in the real world or what their function is. And these are all very stylized, simplified, and made at a different scale. But you can see all the different components here and how they interrelate and get a sense at a glance of how things would work. And you also have these strong lines of sight that allow you to start at one particular point and kind of see how the flow works. Maybe you're looking at coastal winds and rain and seeing how the water flows through and so on and so forth. Or maybe you're starting with the heat. But there are some natural anchors or natural points at which you can kind of jump into a graph like this without being disoriented, right? So this is another graphic I did. I create these graphics for a magazine series I write for at a magazine called Canadian Government Executive Magazine. And this is a diagram for open science. And it's an example where you could see people actually doing the activities that exist within this particular system. So it's like you're able to see all the different pieces, but also people actually doing activities within each of these areas. And a graphic like this, I think, is really useful for a couple of reasons. One is that I've got these little annotations that make a graphic like this a little bit more self-explanatory. So I've written in full sentences, but very simple language, what it is that's taking place in each of these spaces. And that's another good practice that I like to build into my system maps, because you never know who's going to be viewing the system map. And if you have full sentences plus a bit of contextual information, you're able to pass off a map to someone else and they can interpret it without any problems, without having to actually guide them through it all. So that's a good practice when it comes to mapping, because it's not just the people that you're mapping with. A map can be a medium of communication to other people as well. So you want to make it, in my terminology, I like to say it's portable and pliable. Portable in the sense that you can hand it off to people, and it will be self-explanatory. People will be able to interpret it without any guidance. And pliable, which means it's useful. You can actually use it within people's work. So there's lots of things that when I'm developing maps and things like that, there are little things that you can add that make it more useful and better able to integrate into people's workflow or into a project that gets something useful and worthwhile done. So you can download some of these graphics. Very few of them actually relate to systems. Some of them are more about leadership or technology or things like that. They're all free to download, so I encourage you to take a look at that. But this is a graphic that comes from one of my mentors who created a company called Explain, based in St. Louis in the United States. And this is showing a system that's a warehouse. And you're seeing a path of progression through the warehouse where you see how a process unfolds. But this graphic is also pulling out objects and magnifying them. So you can see important parts of the system that are also emphasized and explained because they're particularly important for how the system works. You also see little labels pointing out different parts of the system. And this is looking at a graphic like this, which is done in a three-dimensional isometric format, is very useful because it creates what I call the mezzanine effect, which is if you're in a hotel lobby at maybe the mezzanine level and you're able to look down at people on the first floor, so you're like one floor up, you can see the system or see what people are actually doing at a kind of bird's eye view, where you still get enough detail that you can see what's going on, so not so high up, but nonetheless you're able to see what actually people are doing within the system at a high level of detail, but also see the whole system at once. So it's a very useful method. And you can actually divide a system, like a map like this, into different parts. So this is another part of the map that zooms out even further, so you can see how the warehouse would relate to distributing products to various other organizations and how that part of the system works. But then again, you still have these call-out circles or call-out boxes that allow you to zoom in and see particularly salient or noteworthy parts of the system. And then you have the annotations there as well that help explain things. And this map even shows at the very top, you can kind of see a scenario unfolding and how different parts of the scenario invoke different parts of the system, right? Sometimes systems get very complicated, so you often develop what I call a bricolage strategy, which bricolage, I guess is a French word. It just means it's like a collage of things, all sorts of different things are placed on a board. So maybe you have graphs, maybe you have other types of data displays, maybe you have some illustrations, maybe you have some diagrams, but they're all kind of put together and fit together in ways that help make sense. So this is what's sometimes called a gigamap or a synthesis map. And it's a giant poster that kind of goes on and on and on for quite a long time, where you're piecing together, trying to be very comprehensive and building in scenarios and sub-processes and things like that into the system. This has a high level of abstraction to it, but you notice that there are things that are smaller and larger depending on their level of importance. And there's a lot of differentiation between different pieces of this. One of the things to worry about with something like this, however, is that you want to avoid miscellany, too much visual miscellany, or too many trivial elements like factoids or tangents or relatively unimportant things taking up a lot of space with a graphic like this. You want to have a little bit more prioritization so that you could see how things integrate into a whole, not just a display of different parts, right? That's one of the definitions of what a system is. You're able to kind of see parts and how they relate to wholes. That's an important feature of mapping as well. Now, I come from a background where I did a lot of my learning on information graphic design from people who work in the magazine and newspaper industry. So I went to study at, I went around the world looking for various people to kind of teach me, and I've been taught by people who work for National Geographic and New York Times and some of these famous information designers. And one thing that you find in this particular style of information graphic, this is what's often called the science fair graphic. It's like if you have a display, a science display, or like a display in a museum that shows a scientific subject area, you'll notice that it has a few features, one of which is that it has these big anchor graphics, which are these big eye-catching graphics that are designed to orient you so that you understand the subject area. And then around that, you see smaller items that explain individual pieces in greater detail. Each one has its own little explanation that has a new graphic attached to it, or a bit of data. And this allows for more efficient kind of guiding of the eye. and is a great way of organizing maps. So with that in mind, what I did is I decided as part of the project, the second phase of the project was to, because I didn't find the ideal notation style, I wanted to go to the flip side, to the other side of things, which is I wanted to jump into the literature on systems theory and systems concepts in all sorts of different subject areas, such as the natural sciences, the social sciences, the managerial disciplines, and the design disciplines, and see what are the different components of systems, and see whether there are certain parts of systems that you can't really map out with some of these notation styles. Because if there are any of these missing pieces, then that would be a type of bias that is self-defeating. It prevents you from really fully representing systems. And I should note that it's really important to visualize systems, because there's so many moving parts, there's so many elements that you have to keep track of at once, that without some sort of external display, it's really hard to keep track of. Because the human mind can only juggle about 7 or 8 items in short-term memory at once before you really start to make errors and you really start to tax concentration. It becomes very exhausting. So I tend to work in what are called codexes, which are, when I'm teaching, I'm often showing people lots of these big inventories of examples. So this is an example of a codex explaining how comic books work, where I take, these are the individual components of what makes a comic book function, like little text bubbles and particular types of lines that have particular meaning. And if you didn't really understand what these things are, it'd be very difficult to understand how a comic book worked. So there's a value, a teaching value for developing these comprehensive inventories, because students, even if they don't understand the subject area, just the act of kind of going through a big inventory can help them understand a major subject area. Now, in the world of management and popular management, you often find these big idea books that say, here are the 5 habits of successful leaders, or here are the 10 things you need to know in order to run a project, or here are the most important values within an organization. They're trying to distill everything down into a few different items. My approach to doing things is very different, which is quite often there are 1,000 different things that you need to keep track of. Like if you wanted to teach someone leadership, and I've done a lot of leadership teaching over the years, quite often there's like dozens of things related to presentation style that they need to know, dozens of things related to empathizing with others, dozens of things in terms of greeting people, and so there's all sorts of these different subject areas, and becoming a very good leader involves mastering a lot of these different subtopics. So for me, I like to be very precise in the way in which I kind of explore subject areas and try to itemize all of these different pieces in order to develop a better understanding. Because even if you don't understand, even if you don't grasp every single little piece, just by working with the pieces, you start to gain lots of new and interesting insights. I've been very influenced by this project that's from a gentleman named Garcia, an architect who's based in Denmark, who for these various design biennales creates these fold-out maps that explore a particular subject area. They can be something like Antarctica, or archives, or quarantine, or orbital satellites, or something like that. And on one side, they kind of explore conceptually what the subject is. And then on the flip side of this map, they explore some case studies. And the great thing about this map is that it's something that you can kind of fold out, something that you can put on a wall as a reference, something that people can gather around the table and have a dialogue over. And so I like developing information products that have these types of qualities that make it easier to work with in a real world context. So that's where the visual vocabulary poster comes in. This will eventually be a fold-out map with an example on the other side that'll be published. But the idea is to have one kind of big space with which to kind of see all the different components of what a system are. And this is the state of the visual vocabulary at the moment. And what this does is that outlines at the moment 182 different elements or dynamics that you can expect in systems. So I'm going to spend a little bit of time explaining what this is. So as I mentioned, I went through a number of different disciplines to kind of pull out the subject areas. And what I was looking for is both throughout history and across different disciplines, if you look at the genre, what are these kind of enduring elements? What are these kind of enduring themes that kind of cut across disciplines and across the history of the subject area of systems? And the idea is to pull some of those out. So to give you an illustration, if we take 4 different subject areas, maybe economics, biology, engineering, logistics management, they all have these different concepts which are represented by these shapes for how they describe systems. And some subject areas are very systems oriented, like economics and biology, engineering. They're all about systems in one way or another. But there are going to be some of these subject areas that are going to be common. And so I pulled those out immediately. Some of these subject areas are going to be analogous. So they are conceptualized slightly differently. They use a different vocabulary, but they're nonetheless equivalent across the different disciplines. So I tried to kind of pull those out and tried to abstract from them so that we had some sort of common concept. Because the idea is if these people were all working together on a team, they would have a common basis with which to talk about a subject. It isn't important that the way in which the subject is talked about is in a very specialized or disciplinary way. So long as people can relate their own disciplinary knowledge to something that's kind of common. And it's through those conversations that we often find a lot of great collaboration takes place. Now, some of these subject areas are extremely disciplinary, which is they only exist within one particular discipline. And a lot of those have been left out. Now, it might be the case that some of these might be valuable contributions to system science, but haven't just made their way beyond that. And so I'm always on the lookout for those sorts of things where no one's actually applied them in other disciplines. But most of those subject areas have been kind of left out. And then there's these areas which are crossover areas, which are, a concept might exist in a couple of different disciplines, but not across the whole, all sorts of different systems disciplines. And those are often really exciting things to kind of pull out because they suggest that these are very valuable and very useful systems concepts, but there are disciplines out there that have big blind spots that don't really use these concepts. So there's an opportunity to kind of introduce some of these systems concepts into new areas. And so it's important to kind of point out that in order to organize all 182 of these subject areas, I spent a lot of time developing these 6 big categories with which to understand systems. And this is essentially, it took me 4 years to put together this codec, but a lot of that time was spent trying to figure out what the major categories were. And so that's what we find here. So first of all, there are drivers. These are active causes of something happening with the system. It could be like a mover or a flow or an agent. These are things happening directly between items. Next, we have signals, these are the things that kind of, these are communications that potentially trigger some action. Things like feedback, things like status displays, things like that. And they can be sense, sounds, electrical pulses. They can come in different formats depending on the nature of the system. Next, you have states, which are various objects within a system can have different conditions. These might be phases or statuses or modes. And one of the challenges with a lot of these system notations is very few of them are good at actually identifying changes in state between items in a system. The third phase of this project is about introducing animation and motion. And that's kind of one promising area that does a better job of representing these sorts of different states or phases and things. Next you have boundaries, which is systems are made of all sorts of different ways of separating and differentiating different pieces. Some of these can be fixed or movable. They can be real or imaginary. Things can flow through them, or they can be impervious or block things. But systems are often full of these boundaries that kind of divide up different parts of the system. There are relations between systems. Now, these can be short-lived transactions or ongoing relationships, but there's a dynamic between at least two or more objects or type of objects within a system. So relations are the types of things within a system that make them more predictable, because there are certain ways in which pieces of the system interact that you can make generalizations about. And then finally, there's the context within the system or the setting in which the system takes place that can have an influence on how the system works. So it's the physical surroundings or environment, or the concept. It can also be the conceptual sphere. So the ideas or the culture that exists around a system. So those are the 6 main ingredients. And to understand how that kind of works, let's go through a few examples. Like each one of these items in the vocabulary has been assigned an icon. And the icon is designed to be somewhat illustrative of the concepts. That's what makes it visual, which is it makes it easier to kind of work with. And the icon has what we call a reference value, which is, it might not be fully intuitive as to what that means, but after you've seen it a couple of times, plus you read the label, it becomes easier to understand next time you see it. So this is the icon for a tractor. So what could be an attractor? Well, a tractor could be like a big magnet, or it could be gravity, like the way the planet pulls items towards each other, or it can be like a sale at the shopping mall. Sales are designed to attract customers. Or it could be like a flower that's trying to attract a bee by using color, shape, and scent in order to bring the bee in order to kind of cross-fertilize. Or an attractor can be the central business district of a city, sometimes called the metropole of a city, that draws in economic activity. So there's lots of different ways in which we can think of what an attractor is. Likewise, this is the symbol for trail, which is a form of signal, because it leaves behind information about what's happened before. And so we can think of it as, for example, ants. Ants have these elaborate systems for foraging and bringing back food to their nest. And they leave trails of pheromones, which allow them to follow each other and identify food sources. Or it can be a trail can be a bunch of receipts, transactional receipts, or it can be geolocation data, or it can be the worn pattern on the ground showing where lots of people have walked. These are all examples of trails that indicate something about a system. This is the symbol for bottleneck, which is a form of boundary that tends to force activity or a flow through a very narrow opening. And so there's lots of examples of this, like you see queuing up for a service is a form of bottleneck, or a part of assembly line that kind of focuses products so that they each go through a conveyor belt one by one. Like the Panama Canal is an example of a bottleneck for shipping. Or termite mound, for example, has a single opening that makes it easier to defend one particular area. Like has one opening, so it's better able for the termites to police their mound, and as well as stop bacteria from coming into the whole mound. And then we have examples like friction, which come from the domain area, which is there are certain items that cause things to slow down or cause some resistance. It could be everything from speed bumps to organizational meetings or these sorts of things that introduce some sort of resistance, physical resistance or wind resistance or something like that. So those are examples where you can see how they kind of come from various different disciplines and can be applied in different ways. Now, the thing to keep in mind is that this is all Creative Commons free culture license, which means that you can use it any way you want. You can modify it any way you want. You just need to attribute the source. But there's no restrictions on how you use this, because the idea here is to advance the discipline, not to make money on this sort of thing. So now, what are some of the ways in which we can apply this? Well, one is that even if you don't really understand, like one of the great things about a inventory like this is that it puts at your fingertips the entire literature on systems, right, at a particular level. So even if you haven't read all these things, and even if you're only grasping slightly some of these components, it provides you with a stepping stone to jump into a deeper literature. And some of this stuff you can do on your own. So you can take quite often I work with these little chips that show, we'll be working with these chips in a moment, where you take a topic, maybe it's a tractor, and you're exploring a subject area. Maybe it's pandemic. And you start to ask, well, how does this apply to this particular situation? What are the mechanics or dynamics? Can you come up with examples of that? And suddenly you're starting to kind of see the world in terms of these ingredients, these dynamics and these elements. And I call this notion system sight. Once you start to absorb some of these concepts, wherever you go around the world, you're always kind of seeing how systems fit together. It's kind of an orienting and teaching device, right? The more you work with it, the better you're able to work with these concepts of these ingredients, the more of a system you can spot in your own world. So one of the ways in which we apply systems in a dialogue sense is to use what are called these chips. And there are you can download the chips from the website and print them off on normal office paper using office equipment. Or you can, I've also got I also have instructions for professionally publishing these. Like for about $100 you can get a set of these that are plasticky. I don't make any money off of these. I just provide the instructions on how to send it to a printer. But if you've got a local printer that can do this sort of thing, then that's even better. But I've provided some examples of places where you can get this done. So I tend to work with this sort of thing, which are color-coded as well as shape-coded. And to give you a sense of how this works, let's start to jump into the topic of COVID and the pandemic. So here are two examples of masks. One's a normal surgical mask. The other is one of these N95 masks. And if we think about this, a mask is a type of protector. It's supposed to protect, it's another kind of barrier that's designed to prevent something like a virus from getting into your system. We have our bodies that have a lot of protectors, such as the mucosa and the skin are examples of blockers or protectors for our system already. This is just another layer of that. And the idea is also to make it easier for two people to, like there's a gap across which a virus has to cross, right? The whole point of a virus replicating is that a virus isn't a living thing per se. It doesn't move, it just sits there. And it doesn't have the ability to reproduce itself. So it has to infect another person, go from host to host in order to infect cells in which, and transfer its RNA or DNA and then reproduce. But in order to jump from one host to another, it has to get across a gap. And so a mask is a type of thing that allows people to, that makes that gap harder to cross, and allows people to come in closer contact with one another without a risk of infecting each other. You can also think of the gap as, and here I've got my, so it's semi-permeable, which means that air can pass through and certain particles can pass through, but it'll block other things. So that's part of the functional part of the mask. And there are layers to it. So in this diagram, you can see the different layers and what the different layers are intended to do. And is that in Spanish? I think that's in Spanish. So you can read it, but maybe I can't. So, yeah, a lot of the thing about infographics I should also mention is that most of them, like a lot of the best infographics tend to come from the Spanish world. So a lot of them from Latin America and from Spain. And we can also think of masks as having a stock. So one of the problems with coping with a pandemic is that there's a stockpile of masks, and we can experience shortages of those stockpile. And so one of the goals of responding to a pandemic is to redistribute masks to the people who need it most. So in Japan, for example, the Prime Minister Abe sent everybody at least 3 masks so that they could walk around, so everybody didn't have an excuse as to whether they had a mask or not. Which isn't like, because I live in Tokyo part of the time, I know that masks are so cheap that they almost cost nothing. You can get like 50 for, I don't know, $4 US. So just a few pennies. But there's a role in terms of pandemic preparedness of redistributing these sorts of things, right? So we can take one object and we can also apply different system roles or different system qualities to this object as a way of kind of familiarizing ourselves. Now, I'm trying to build out these demonstration cases to show how this kind of mapping process works. One is about, it's called the exurban apiary. It's about bees. The other is kind of a coastal sea farm, which is about sea farming, kelp, and the greenhouse gases and things. And the third one is about pandemics. So we're going to explore that today to some extent. And to give you kind of a sneak peek, this is from an example of some mapping activities. Here I'm using an illustration style, which I often call Linclair or technical illustration style. Here we're drawing connections between different component parts of a system as they relate to the pandemic, and then also assigning kind of labels. And the way this final version is going to work is that I'm also going to be annotating each of these relationships so that they become more self-explanatory. That's kind of one of the ways in which we can explain how a system works, where you can actually see the different objects. Now today we're going to work with a style of illustration that's a little bit more like a doodling. That's a little bit more approachable, so it's ideally a style of illustration that you can do yourself. And here we're exploring a different level of analysis, which is the microscopic level. We're seeing how an individual virome can infect a cell for purposes of replication. And then we can see how an infected cell will give off these interferons, which cause, which are a form of alarm, which cause the B cells to activate. And the B cells create these antibodies. The best ones are sent on to confront the virus. But one of the side effects of interferons is they cause us to have symptoms like coughing symptoms to ward off the infection. And then this creates kind of, this is the mechanism of transmission between people, right? So the very way in which a virus tries to defend the body against a virus is in fact the means of transmission, which is kind of the evolutionary mechanism by which viruses are able to kind of spread. Now, I want to kind of give people a sense of exactly what this can be like by looking at the first demonstration case that's going to be coming out, which is the apiary, or the bee, the factory that collects bee nectar and turns it into honey and things. And this is kind of what it looks like. So it's a design case, which means that there is a solution here that we're trying to put forward and showing how it relates to a bigger system. But we're also seeing how the system works at different levels of analysis. So each panel in this shows a different level of analysis. So the body of the bee, then there's the hive, then there's the foraging process, and so forth. And we don't have time to go into this in detail, but I wanted to just kind of give people a sense of some of the ways in which this works. So, each also has a big challenge. So in the case of the bees, we have this colony collapse disorder where bee colonies are dying out within certainly North America. So this is a big problem. So I've divided it up into different levels of analysis so that we can jump deeply into each one, where it goes from the body of the bee and its colony, and to the apiary as a organization, to the territory in which the bees operate, to society, and then back to a market, and then the body of the human being that's digesting honey and things like that. And that too is a part of a system. Now I can't go through all of this given constraints of time, but I wanted to kind of point out a few dynamics here. So for example, when we see a flower, like bees collect nectar and pollen from a flower. Nectar is a source of sugars and pollen is a source of protein. And the flower benefits as well. And I'll mention that in a moment. But one of the problems with, if you have something like a sunflower, is that a sunflower is attracted by various crop pests, which are kind of these are parasitic relationships with the flowers. And so farmers will identify this as kind of a threat, a proximate driver to what's causing their crops not to have a high yield. So in order to confront that, they'll provide an opposing mechanism or opposing force, which is pesticides. The problem with pesticides is that the pesticides will attach to the body of the bee, and the bee will take it back to the hive, and it'll start to accumulate within the honeycomb wax in the hive, which is a form of contamination. And the wax is reused over and over again for many years, sometimes over 10 years, 12 years. And so what that does is it's a toxin that causes the larva to grow more slowly. So there's a lag that's produced. The larva, as it's developing from an egg to a fully adult bee, will stay in this larva state for an extra 2 weeks. And that extra 2 weeks provides an additional vector for other types of parasites to invade the hive. So just by mapping out this very kind of simple dynamic, we're able to identify one of the potential causes of this colony collapse disorder, right? So I wanted to also point out, like here's an example from the hive as a design object, where we create this hive. And it's got it's designed to mimic a real life beehive. It's got a gap, like it's raised up above the ground so that bears don't attack it. It's using recyclable materials so that they biodegrade, and so forth. And it has different compartments in order to facilitate different activities, so the queen doesn't able to move beyond a particular barrier. There's redundancy, so there's extra honey in the system, so that if, for example, the hive goes through hard times, they have a surplus of resources. But also, this is the value that the beekeeper harvests. And it's an auto environment, which means that it's an environment that's controlled for temperature and airflow and things. It's an environment that responds to the presence of the bees. And there is this gate at the beginning that acts as a bit of bottleneck. And this serves a number of purposes. It makes the hive easier to defend against, and so forth. And there's other thing that I wanted to kind of point out, which is actually I'll point out two other things. One is that if we think about the processes that a hive produces, we see some very interesting system dynamics. So one is that the bee will go out to flowers in order to collect nectar and pollen. And there's a mutual relationship between the two because both the flower and the bees benefit. So the bee is able to kind of identify certain characteristics of the flower and is attracted to it. On the body of the bee, various pollen kind of accumulates, so it's kind of like a load. And the bee actually collects pollen on its legs as well in little baskets. That as the bee jumps from flower to flower, it redistributes the pollen to another flower, which is a form of cross-pollination, which helps the genetic diversity of the flower. But for the bee, we find that it's able to gather, when it comes to nectar, 10 times as much energy as it consumes, or pollen, it collects 8 times as much energy as it consumes. So there's a goal of harvesting resources for energy purposes. I just have to quickly, and the other thing to keep in mind is that both the pollen and nectar collection are happening at the same time, as well as other functions of the hive. There's a special stomach in the bee that's able to transport nectar, and these baskets on the sides of the legs to transport pollen that's brought back to the hive. When the bee gets back to the hive, it regurgitates the nectar and gives it to another bee, so it's an intermediary who then stores it in the right spot. And then that creates a stockpile of honey in these combs. And the other thing that's interesting is that this whole process is governed by a type of dancing, a waggle dance. And the different ways in which the dancing bees dance shows where the sources of honey and nectar are. So there's an exchange of information, but there are very specific reference points the bee is communicating depending on how it's waggling, which will communicate distance. But the direction it's pointing in will also use the sun and the comb grid as reference points with which to point other bees in the right direction. And the way that kind of works is that it's kind of interesting, which is, let me just move this over. So first of all, there's a kind of competition between different bees as they're performing these dances. The ones that are more enthusiastic are the ones that are able to garner the more attention. And so they're kind of framing exactly, their excitement is kind of framing the extent to which there's likely to be a very rich source of food. There's also an effect where, a cascading effect where the more bees go and find food at this great spot, the more they'll come back and do that same dance. So it's an amplification of this signal that shows where the honey is. And as that source of honey is depleted, there's a decay of that signal. So fewer bees will come back and signal that this is the best spot to go to. And what all this whole process is kind of a wisdom of crowds. It's a kind of co-processing where the bees are able to come to very sophisticated decisions about how to forage. And I also want to just point out very quickly that you can also map this across time and across space. So time, you might think of it as a cycle across the years where the cycle, there's a synchronization that takes place. depending on where the sun is in the sky, so it's synchronized to the solar system. That provides a cue for the bees to start producing a new brood or a new crop of bees. And it activates them in the middle of the winter. There's a tipping point at which the bees then realize that they have to go foraging. And it's through this very limited window of time that they'll, basically 14 to 16 weeks, that they'll then gather the stock. I should point out that this is different in Mexico. The reference case that I'm using here is from the northern United States and southern Canada. So in Mexico, the way that this cycle happens is very different. It could happen year round. And at one point, the drone bees, the male bees and the queen bee will network with other hives in order to help reproduce and improve the genetic diversity. But also sometimes queen bee and a bunch of bees will leave to create up and set up a new hive. So it helps scale the whole operation. And then there's an inflection point at which time it becomes clear that now that the winter is coming again, that the hive will not be sustainable given how much resources are being consumed. So then some of the bees are evicted from the hive and essentially killed so that the remaining bees can survive to the next cycle. So that shows how it all happens over the cycle. And what's interesting here is that if we're thinking about colony collapse disorder, any little interruption in this process, so they're not able to get enough stock, or something interrupts them in some way, or it's a late start, or climate change, or these sorts of things can cause this sort of collapse disorder. Because if they don't have enough resources by the time this particular inflection point happens, then everyone will die and the colony will collapse. Now, there's other ways of doing this. You can, like condition shock would be example from global warming. I'm not going to go through this in detail, but you can also see how if we map this out over a space like a suburbs to the excerpt to the countryside, you can also start mapping things out that way. We don't have time to go through all of this, so I'm just going to note that it's going to be continued, where I'll eventually be publishing this as a demonstration case so that you can go through this yourself. But what I wanted to do today is I wanted to play around with the visual vocabulary when it comes to the pandemic. And so we want to go to the Miro board. And so this is a good time to kind of pause, answer any questions that you might have, but also share the Miro board link so that I can let people in if need be.
Okay, yeah, I can share the link again here, Peter, in the chat.
Okay.
And before we go to the Miro, does anybody have any question? So you can open your mic and directly ask it, or either write it in the chat.
So here's the Miro board link. You can just tap on that link and it'll take you to a web page.
So I don't think we have any questions at this point, Peter. So perhaps we can move to the Miro. I'm sure, I think Daniel has one. Daniel, do you want to open up your mic?
Yes.
Thank you.
Thank you, Gaby. Thank you, Peter, for the presentation. Just a quick question on a side note. Given your experience on working with different public institutions or government offices, for public servants and also in international organizations, it is most common to work with reports and data, quantitative data. So this issue of working with visualizations or graphics, not as an end product, but as part of the process, whether it's for analysis of a challenge or for formulating a solution, is not a usual practice within our areas. So in your experience, what kind of advice would you give for people that are not used to use these kind of tools first? What are the do's and don'ts when one tries to transition from just data and word reporting to this kind of tools, for instance?
That's a great question. And it basically the answer is, I've devoted my entire life to adding visuals to the ways in which public servants do their job. So that's that's the whole reason why I became an information designer, basically, is to do that. And the thing is that I'm extremely successful in doing this, because once people see the value of doing this in a new way, they never really want to go back. And I tell people this in a few ways. One is that I tell my clients, especially in government, I say to them, no one's reading your materials. No one's reading these things. One of the, there's a saying in French, which is that people start to read diagonally. Instead of reading every sentence, they just kind of read the first couple of words of a paragraph and then the last couple of words and maybe a word in the middle. So it's how they start to skim read these government reports, because they're written in such a dry language, a passive voice with lots of jargon and acronyms, and all of these kind of problematic ways of communicating that people just start to glance past. And I tell people, sometimes when I'm working at the cabinet level or ministerial level, I tell people, listen, we're going to have a cabinet meeting where a bunch of ministers are going to be here. And I make you a bet. I bet the information that I'm going to present to you is going to completely blow away the information you're going to present in that binder that you've just dropped on the table. And everyone's going to come back remembering what I provide, and they're going to forget what you provide. So it's going to it's a very arrogant way of presenting the case. But quite often when you're developing things like visual posters, for example, it will literally at the table cover up binders. Like it'll be on top of the binders, and people won't, like it's the type of thing that will grab attention. People will find it more interesting, and it'll put more information at people's fingertips during the conversation. So I've literally done with what are called placemats, where I've outlined sometimes data, sometimes a system, in a poster that can just fit in front of someone at a meeting, and it has two sides, and it puts so much information at people's fingertips as they're having a conversation at a meeting, whereas flipping through a binder or a report interrupts the conversation flow and causes all sorts of problems that way. And people get into these conversations about negotiating the meaning of a term or some things like this, as opposed to having a deeper conversation of the subject matter. So once you introduce people to this, they start to get more excited about this method. And the more you create graphics like the 3-dimensional graphics that I showed, I have a lot of them circulating in Government of Canada right now. And it's amazing how fast that they spread, because they come with the motivation to spread. I did a graphic for the Transportation Ministry in Canada, in Ottawa, and then I went to teach a course on the other side of the country, so 2,000 kilometers away, in Victoria, near Vancouver on the other side of the country. And my graphic had gone, like I was teaching at a public admin school that happened to have a couple of people from the Transportation Ministry attending. And my graphic got there before I did, and they were circulating it amongst people already. And so they already knew who I was. And it's hard to think about information that spreads so quickly sometimes, right? That's the power of information graphics. And the other thing that's important is that you're not only providing, because it has a motivation to spread, but you're providing the tools with which to allow other people to teach other people, right? It can be kind of like a teaching tool. So there's a whole universe. Like I have a whole presentation, like a hour-long presentation about the methods of doing this in a public service. So maybe for another time. But so there's lots of, so the opportunity here is really vast, and there will be sources of resistance where people, because it's unfamiliar. But that's not, I find that very easy to kind of overcome that kind of resistance if everything's done well. The problem is that sometimes with some of these infographics, if they're done poorly, people just brush them off, right? Yeah. So there has to be some, there is a method to designing these kind of visuals that you want to follow.
Gracias, Peter.
So, Peter, we have another question in the chat, and it's regarding the resources that are needed to create this type of visual maps. So the first part of the questions is, who would be the ideal team to craft a visual map? Would it be like designers or illustrators? And how much time does it require?
Well, I remember giving you the answer to this question when we talked when I was in Mexico City, which is sometimes when I'm doing this, when I'm developing a map that's meant for a real project, not just kind of for learning, but for a real project, quite often we'll work for 2 or 3 days exploring and doing proper research in order to kind of build out the map. And we'll be able to continue to build out the map afterwards as well. The technical skills needed for building a map like this, I like to think that they are available to anybody. And what you really want to do is the idea of creating a team is to create a diverse team. People that can see different parts of the system. So Peter Jones, who works for who helped form the Association for Design, systems-oriented design, says that the best way of composing a team, a participatory team, is to invite the system into the team, or the people who have exposure to different parts of the system, so that they can kind of share what they know. There are some facilitation techniques that I can recommend, but and maybe I've got an information graphic that I can share on that topic. But the real point is that if you're working on something that focuses your attention and you're working on a task, you don't really need a lot of facilitation. Everybody can kind of, once they understand the basic rules, they can kind of all work together without any kind of, in a natural flow, provided they kind of start to understand the tools and start to kind of work with this particular type of system. There aren't the actual illustration skills that are required are very minimal. But they can be elaborate also. So sometimes you might want to hire an illustrator. But the point is that when you're mapping initially, it'll be very crude, it'll be very basic. And then as you evolve it into different iterations, you can make it more and more polished. The point of the chips and the vocabulary is that you have a little bit of visuals already given to you. And then you can kind of draw very simple illustrations from there. And so the technique that we're going to use today is going to show an example of a very simple style of illustration, doodle kind of sketchy style, to show you how quickly an illustration can be formed. All of these illustrations that I'll show today, I did in maybe a minute or less, like very quickly.
Okay. Thank you, Peter. So I think we can move to the Miro board. I mean, I have a few more questions, but I'm going to save them to the end.
Okay.
So everyone, I'm gonna post again the link that Peter gave us here in the chat. So if everyone could go to this board, please. Okay.
Okay, is everyone able to kind of access the board? I've got it's asking me to give some access requests.
To the Miro board?
Yeah, so I've given them access request, like but everyone's able to see. I notice there's 17 people on the board at the moment, so people are moving in. Oh, and I see some people moving around now.
Yeah.
Okay. So I'm going to share my screen, and so we can go to, I can kind of show you how this works. Keeping in mind that this is kind of a, this is a experimental way of doing this. So normally we do this live with the chips that are like these little plasticky pieces or these little paper pieces. And I'm going to show you a little bit about how I lay this out. So here's the visual vocabulary itself. It's the same as the one on the poster, but it is in the form of these chips. And each chip has an icon, a label, and then a generic description. So normally we'd be able to kind of play with these, but they're divided into the 6 different families. Now, when you're working with these, you can just kind of highlight one and then copy. So you just kind of copy the item, and then you can kind of paste it. So cut and paste. So that you can then move this around. Otherwise, these pieces here are locked. Or you can delete those. Now, what I have here are, because we're going to discuss COVID, I've got a number of illustrations here that point to different parts of the system. So greeting habits, so like examples of handshaking or hand washing and these sorts of things. And so what we're going to do is I've got these spaces on the sides, A, B, and C, and we're going to look at the pandemic from 3 points of view. One is the point of view of the interpersonal space, or networks, or how people interrelate as it relates to the pandemic, because the virus kind of spreads from interpersonal contact. So we can think of this as a system in terms of people's interrelationships. But also we can think of this as kind of information space. So it's all about sending information, public information, people kind of figuring out what to do given the threat posed by the pandemic, what kind of advice, how does expert advice circulate through the system, all these sorts of information elements. And then the third piece is the treatment space, which is hospitals and that sort of thing, actually treating individual patients. So as I'm looking through the subject area, these are 3 sub areas of levels of analysis that I think are kind of useful ways of jumping into the topic. I have a few others. So for example, during the animation, I showed looking at it from the cellular level, so the microscopic level. And we can even look at this in terms of deeper supply chains for medical supplies and things like that. But this is a good place to start. And when I'm doing this type of analysis, sometimes it's useful to start with a seed object. That's where we just take one of these, like one illustration or one topic, and then start to explore from there. So I'll give you some examples. But one thing to note also is that I have a few generic items here on the side, done in 2 different illustration styles. So this is the more technical illustration style, and this is the kind of stick figure style. And I have a few subjects that you can kind of fill in. So it's like individuals, groups, organizations, and then technologies or platforms. And sometimes it's useful to have when you're doing this in a group session, to have cards that also have these things where you can assign, for example, there might be a particular role or a particular interest or stakeholder or something like that you want to kind of just write in advance. And normally when I'm doing all this illustration, I'd be doing it live. I'd be drawing it live on a board. but I pre-prepared a bunch of them that for the online version to make it a little bit easier to work with. So if we're talking about interpersonal, let's focus on a few. Let's take a look at a few things. So maybe we can look at these haven't been. These are kind of all mixed up, but that's okay. So let's start with kind of this person here, where someone's been infected by the illness. They've come across the virus, and the virus is, this is a virome. And maybe it's just been on a surface and they touch their face with that, what have you. But they've kind of, you can think of this in terms of exposure. I'm laying a few pieces here. You can think of physical distancing. So, so let's look at this in terms of the system. So first of all, we have the virus, the virome or the virus, which is an actant. It's something that's actually, even though it's kind of an inert object, once it interacts with an individual, it becomes active and it becomes a kind of a live thing. A virus, though, it's also important to point out that a virus is a container. So the virome has a payload. It contains, in the case of COVID-19, it contains RNA. And RNA is a set of instructions for reproducing. So its payload is a set of instructions that allows it to reproduce. Now, we can go into detail on how it does so because it interacts with a cell, and there are, that's a different level of analysis. But it's important to kind of point out what's going on here. But all of the selection pressures of how the virus adapts all happen in transmission. So it's jumping from one host to another is how that works, and we can think of this as kind of like at this level of analysis, we can think of this as kind of like a contamination or an infection of sorts. Contamination is one of the handy objects we have here. Can't seem to see it off the top of my head. Must be, anyways. But a few things that I'm going to pull out instead are as we start working with this and become more familiar with how they're arranged, we can move faster. Now, the thing about an individual who's now redistributing the virus. So an individual is now containing a viral, what we call a viral load. Someone who's been infected is containing a load, and they're moving it around. And it's the gap between individuals that it has to jump across in order to reproduce. So there is a goal-directed activity in terms of the virus. it's got a goal-directed activity, and that goal-directed activity is to reproduce, replication, and in order to do so, it has to get a host, to move it around, to cross a gap to another host, through exposure. Now, one of the things that we can do is we can increase that gap by increasing the physical distance, right? So we're increasing the gap. And we can kind of note that, right? We can annotate this by saying to meter, distance increase across. So we can annotate that. Whoops. But we can also think of this in terms of what happens when we introduce masks. A mask also affects that gap by making it harder for the virus to jump across. What is a mask? Well, we already discussed masks. Masks are protectors that help protect an individual from getting the virus. It also has, as we discussed before, it's got a filtering quality. So you can also start drawing arrows across between things. This particular, one of the problems with this particular type of tool is that it doesn't do a good job of, normally what we'd want is we want arrows that are much larger in size, so that it's more obvious that there's a linkage taking place here. What happens when someone then starts to get ill is we now have to start thinking a little bit about how this maybe unfolds over time, for example. So maybe we have, I'm just going to talk my way through this before we kind of make this a little bit more interactive. So they might not experience symptoms right away as they walk away. And that's significant because symptoms are a form of signal. Symptoms are a form of signal that tells something about the status of a person in terms of illness. But they're not showing symptoms. And the reason why is that there could be a lag of time before they get infected and they're showing symptoms. So we're seeing a lag. And again, we can be annotating this to make it more self-explanatory. Takes 2 days before symptoms appear, in order to make this a little bit more self-explanatory. So this is one of the major causes we don't really have a way of telling whether this person is sick or not. So one of the ways in which we compensate for that is that we have tests, and that starts to enter us into the treatment space, because tests will give us this indicator that we need. Then again, it's also, as we note, that there's a whole part of the system that goes towards processing those kits, right? You have to send the kits to a lab. The lab then gives you the results. So we should have so we have testing lab. And then the results will show up on usually someone's smartphone. But as one of the problems with the processing of all of this is that we have a, oops, no, there we go. One of the problems with the processing of this is that we have a bit of a bottleneck, which is right. Bottleneck. There we go. As we work with these, they kind of easier to kind of, and we have another lag, which is maybe the test results show up in 24 hours, but still that gives us, we're only closing the asymptomatic spread by a day. So we can, this is kind of, we can label this is kind of like the, you can assign it a label like tests. This will link on to all sorts of other things. One of the side effects, interestingly, in a lot of, we can think of this in terms of also some of the unanticipated side effects that happen when we're when we're implementing a process like this. So one of the unanticipated side effects of running tests like this was that we suddenly got all sorts of basic medical supply shortages. So we started running out of swabs and things, because swabs and so forth are a form of stock. We have to have an inventory of those. And ideally, you, in a highly prepared system, you have them available in advance in significant quantities. But if they're not, then you have to reorder them. And then the part of the system that you have to start invoking is the whole supply chain. And one of the interesting things about this pandemic that we've learned is that the most basic supplies, like swabs and things like that, are often the hardest things for a supply chain to reproduce on short notice, because they tend to be very inexpensive, very low profit margin products. So that increases, so there's often a replenishment lag that happens there, plus other sorts of cost problems, right? So here we're starting to see already that's how the system has introducing all of these kind of lags and these unanticipated side effects, just with trying to get a better sense of telling who has the disease, right? Having some sort of status display to show who has the disease. But eventually, they'll start to show symptoms, or some people may not. So that's also a possibility too. This then makes transmission much easier, because we're now seeing a diffusion of the virus on surfaces and things like that. Although interestingly, one of the interesting things about that we also learned from research evidence is that certain types of surfaces will cause the virus to be damaged, because one example of that is copper. So if you've got surface made of copper, so door handles that are made of copper, the virus will more or less be killed instantly. And that's because the virus itself has a boundary, because it's a container with a boundary. And if you damage that outer boundary, which is what's called an enveloped virus, then you it affects the compatibility between the virus and the host cell, which is affects the interoperability, because the technical explanation is that the spike proteins that interface with an actual cell become damaged, and this affects the ability of a virus to connect to a cell. Now, when we're starting to map some of this stuff out, one of the things that's really interesting is that here's we can start doing hand washing. It's another example of a activity that can start to serve as a barrier. And we also have to worry about things like, where was it? Greeting norms and greeting behaviors. These are things that, where am I? These are things that can affect the spread of increased contact, and they help close this gap, right? So greeting norms like handshaking and things like that make this gap much shorter and make it easier to kind of bridge across. So we can think of this as bridging across a gap, so to speak. And this sort of greeting habit will act as a bridge across this gap to the virus. But there's a few interesting cases here that you might, that as you kind of explore the case, you start to take note of. So, for example, some people, here we're looking at exposure between two people. Some people are super connectors, which means they interact with lots of other people. So this makes the potential for diffusion to be particularly large, right? Because they have so many people that they can kind of infect, these super connectors. We also have, we also have what are called super spreaders. Right? And super spreaders are people who physically are able to convey large loads of virus to another person. Right? So they have very large loads. So in a few senses, one is that there's high concentration, but we can also think of this as load. We're starting to see how these are going to be particularly important cases. Or we have the super spreader events, which are things like crowds or football matches or situations where there's a lot of close contact between people. Which can all of a sudden start to create large waves of cases. And so these might be some of the things we want to focus on, because we know that, for example, something like 90% of, I don't know the number off the top of my head, but 90% of cases of infections come from 10% of cases of individuals. And it's super spreader events, for example, sometimes it's the nature of the activity. So that's where you might have to start thinking a little bit more carefully about things like airflow, because if people are in an indoor restaurant, so both humidity and airflow in the space can be very important. Factors in spreading amongst crowds. And these are attributes of the space itself. So air conditioning is a type of auto environment or climate control that reduces humidity, but it also increases the spread, because if you have a humid environment, when the virus is coming from your mouth, it's dropping to the ground faster. Or air circulation is a factor that kind of amplifies the spread in the air. So lots of air movement can be an amplifying effect. And so right off the bat, we've just kind of taken something very simple, which is a sequence of interactions between an individual and their exposure. And we're already identifying some key pieces that we might want to focus our attention on, such as here are aspects of a system when it comes to greeting habits that we might want to focus on. Although even then we might have a few problem cases. So let me take an example of there are always going to be people in a society who don't want to follow the rules or the norms. We call these in systems, these are thought of as confounds. So a confound is someone who's working against the activity of a system and creating a problematic situation. So people of this particular type of, who are violating the rules and are undermining some of these interventions like hand washing and physical distance, create a problem. Here we might then start having to do some things like impose some coercive power to prevent them from acting in this particular way. So there might be control points, for example, where we might want to intervene or to prevent them from flooding rules. Oops. Sorry. 12 points. Prevent them from flooding rules. There's also ways in which we can prevent a lot of this exposure, completely sidestep it. You can also see the formation of another intervention, which is to, once we've developed testing capabilities, we can kind of trace who they've been in contact with in order to track waves of people. And in so doing, we can kind of once we track, we can implement policies that kind of oppose the virus. We can also find some of the ways in which we can overcome some of these dynamics related to the superconnectors are forms of isolation or things like bubbles. So a bubbling strategy will be something like letting people interact with small groups of people, but not outside of that small group. So what we're doing is we are causing people to cluster. And then we're causing people to cluster in the system. And then we're building barriers between, we're building separators between that cluster and other clusters. So that's the system dynamic that we're creating. And the benefit of this is that it prevents from these super spreaders or these super connectors, it prevents them from crossing across these boundaries. So we're we're starting to build some barriers between some of these super connectors and the rest of the population. We're preventing them from being quite as effective networkers. So we think of this in terms of a relationship, an actual system relationship, and that system relationship is networking, which is, where's my networking relationship? There it is. So we're interrupting, essentially what we're doing is we're interrupting networks. So it's, and maybe we, at this point, we can open it up, and we've only been doing this for a few minutes, but already we're starting to see how we can kind of build out a system and see some of the systemic linkages. Maybe we can open it up to conversation to, if people have any suggestions or questions that might help us expand this further, or any kind of ideas or impressions on what we've done so far.
If anyone has any questions, please, you can open your mic or write it down in the chat. Well, I guess maybe in the meantime, if people come up with some questions, Peter, I have a few remarks and reflections from what you've been sharing with us. I guess also to trying to tie it back to the work that we do at UNDP and how these type of tools could be useful for what we do here in Mexico. I guess one of the things that we found really interesting about this is that what happens after we map the system. I guess it is a way to identify the type of interventions or actions that we would like to enact, or it could inform the creation of a strategy, right? So I guess the value that we see in this tool that Peter shared with us is in how it can help us detonate and create dialogues and discussions among our government counterparts, people at a country office, civil society, and so on, the whole ecosystem, so that we can find a way to have a shared understanding of the system that we want to intervene. And it's also very useful that it can be applied to a variety of topics. Like when I met Peter, it was a workshop here in Mexico, and what we did is that we mapped domestic violence, which is a topic that UNDP is working on. And it can give us a sense of the type of interventions that we can create or work on to address the issue from multiple angles. I would say also important is to have in mind that a system is not a clear-cut thing to do. Like there are a lot of biases and assumptions that we have. So that's why I think it's wonderful that Peter stresses the fact that to have the diversity of group of people within the group discussing the system is what enriches the conversation. And we can also even map where are some disagreements or alternatives, because maybe we don't see the system the same way, because also like all the cultural norms and beliefs and so on also play here an important role of what issues are being considered as being part of a system. So that's something that I had in mind from now on my side. I also want to open up again the floor to see if there are more people that have any comments or remarks or questions. Please go ahead.
I have a question, Peter. This is
Okay.
Luis from the Accelerator Lab. So I was also like playing a little bit with the board, trying to come up with a system in the area of information space, the C. Mm-hmm. And one of the things that I stumbled upon is that, well, naturally I can see that this becomes an easier exercise to make once you have a better domain of the different icons. Like I found myself having the idea already in my mind, and then going back to the different set of cards to try to find it. So what would you suggest to be a good way of maybe throughout a game or throughout some dynamic, so that the group at first can familiarize themselves with the incredible amount of different topics and definitions that you have come up so far? I feel like that would be like a good starting point, and maybe you've had some experience. I sense that people can get better at this once they dominate better the concepts.
Yeah. So there's a few things that you can do. One is that you can pull out some of the more basic concepts to work with, like a subset, and then start with that, and then work to more advanced things. And when people find that they can't go much further with one particular group of these concepts, you start adding in more as they become appropriate. So it's good that if you're a facilitator, to become a little bit more familiar with the items. Another way of doing this is to do it as I mentioned in the presentation, which is maybe you just start taking you start with the topic itself. And from there, you start thinking about what are some of the problems. So for example, side effects are an example of a subject where you can apply unanticipated side effects to almost everything. For example, super spreader events, what are some of the side effects of this? Or particular design decisions or things like that. And you can just start itemizing side effects as an example. Or you can take a very basic set, which could be things like, what are the drivers? What are the enablers? What are the opposers? And maybe we can kind of think a little bit more in terms of motives and goals of each. And you can just take a very simple subset, and essentially what you're doing is if you just take these four, for example, and we move them down here, we've created a template, like a little dialogue template, where it's like, we can take a particular topic, and maybe the topic is something like product shortages, right? So we notice that all of a sudden there are product shortages in the stores. Okay, so what are the causes of this? Well, we might start to say, well, some of the causes might be hoarding behavior.
Hoarding, yeah.
Yeah, because I drew a little hoarding behavior icon.
Yeah, I saw there's a guy holding a bunch of boxes.
Yeah, where did he go?
There it is. I can see it in.
Oh, there we go. So we can start exploring that, and then we can also replicate this, which is, okay, so what are the causes of the hoarding behavior? Right? So these are product shortages. That's on the demand side. Maybe on the supply side, it's like interruption of supply chains. So maybe we create because you don't have supply chains. And we can just take a small subset and start exploring that, right? So we've essentially taken a very simple template, and we're mapping it out by just focusing on this limited set of things. And it's from there that we can then start to look more, we can start to maybe pull in some interesting features like like aspects of the domain that might, like another interesting thing that I like to pull out, something like cross-domain risk. So in what way does a product shortage create risk elsewhere in the system, within another domain in the system or somewhere else in the system? How does it create other forms of risk? How does hoarding behavior create other forms of risk? And we start just kind of expanding the template, right? That's another way of doing it. If you're not as familiar with the chips right at the beginning, and then you just kind of expand your repertoire from there. So that's another way of doing it.
Okay, thank you.
Thank you, Peter. So I'm thinking that we are, it's a little bit past 11. So I'm just gonna, ask if anyone has one last remark or pressing question that you would like to pose, then please feel free to do so. Otherwise, I would like to thank you a lot, Peter, for sharing your time and your experience and knowledge with us. And also to the rest of the UNDP team, telling you that if you want to know a little bit more about this method or see how you could apply it to one of the projects that you have, also reach out to the Accelerator Lab team and we would be happy to help. And on that note, I would like to thank everyone for joining us today. And that's it. Have a nice day.
Thank you. Thanks, everyone.
Thank you all.
Thank you. We shared some of the links on the chat so you can see where to download the System V's poster, and also one example of a project that we conducted on the domestic violence example that we mentioned. And that's it. Thank you so much.
Thank you all.
Great. Well, I'm going to keep this board up for a few days, and so if you want to kind of play with it, then that'd be great. And I'm going to play around with it a little bit more myself, and so maybe I'll be able to kind of put up something from the session as well, just as a bit of a quick reminder. So feel free to play with all this, and if you have any questions or any feedback, that would be greatly appreciated. And I'm glad to help in any way. And just let me know. Thanks, everyone.
Thank you, Peter. Bye.
Bye. Gracias.